Welcome to the Gestalt IT Rundown, where each time we meet, we run down the week's IT news stories, sometimes with insight and always with a little bit of snark. I'm your host, Stephen Foskett, publisher of Gestalt IT. Joining me today is a special co-host, Calvin Hendryx-Parker. Welcome to the show, Calvin.
It's great to be here.
It's great to have you. Thank you for joining us. Let's jump into the news of the day.
All right.
You may have heard of a long simmering battle between Google and Oracle over the public API of Java. This dates way back to before the dinosaurs roamed the earth. Oh, actually only to before Java was part of Oracle. Android as a platform was created in the mid-2000s, and Google based its mobile operating system on Java APIs to make it much more approachable and usable for developers. They got in a bit of a punch in the face when Oracle acquired Sun and decided to sue them for copyright infringement. Lots of back and forth, lots of court cases, and we finally have a ruling by the Supremes. So what does Diana Ross say about this?
Oh, as much as I love to bash on Oracle, I think it really is a good move here. They went back and forth forever on this through the courts. Maybe the only people who actually profited from this whole maneuver has been the lawyers along the way. But I do like to see the fact that we can't say that a publicly accessible and documented API is a copyrighted, uninfringible type of a piece of material. I really think that this will impede other people building innovative software down the line. Same kind of goes for software patents. I'm not a huge fan of software patents either, because many people can arrive at similar solutions. If you put enough monkeys in a room, I'm sure they can type up the same piece of code given enough time. Not to say that the developers are all monkeys, but I feel like we can't stand in the way of innovation here. And that's what this was doing. Only the lawyers were benefiting from this whole maneuver along the way. But it's nice to see that there's finally been like a line drawn. Oracle is going to have to back down, and Google gets to have its way finally. I'm just trying to think of the amount of resources that have gone into this that could have gone into actually making Android an even better product than it is. When enterprises have to spend this amount of money, kind of toiling away at legal battles, I think it just hurts the consumers in the end. The consumers didn't get a better product in the end with that much resources going toward a legal battle. So it seems strange, Stephen, but you might not be able to buy a new car right now. And it's not because of a shortage of steel. Instead, automakers can't source silicon chips they need due to the global supply crunch. The same is true of many enterprise IT products, and we expect this to impact the cost of everything from phones to laptops. What is going on here?
Well, this is a really weird story. I think that most of us can kind of think, okay, Apple comes out with a new phone, uses up all the chip space to make all the CPUs for their phone, and it puts like a crunch temporarily on the availability of GPUs or something. Or, okay, maybe, Bitcoin is big and people are buying a bunch of ASICs, or maybe, people are buying a bunch of GPUs for that or whatever. But it's not that. It's not any of these things. Instead, what we had was a combination of weird things coming out of the pandemic. So basically going into the pandemic, well, everybody panicked, and the automakers decided, well, you know what, we're going to just not order our replacement, the chips to make the electronics to make the cars, because we don't know how many cars we're going to be making, and maybe we'll delay some product or whatever. At the same time, we did have, this global like Bitcoin phenomenon. We had people, later in the fall, Ethereum started going up, people started gobbling up GPUs. NVIDIA had a new generation, and so people started gobbling up those. Apple came out with a new phone, Intel's got new products. Everybody's working at home and they're using the cloud like crazy. And now people want to go buy cars and they can't. And they can't because there aren't no chips for the cars. And it's just this global supply shortage of silicon chips. And compounding this, we've got some problems too in the supply chain. So basically chips are made out of silicon blobs, and these silicon blobs are made at special places, blob making factories. That's the technical term for them. And a bunch of these blob factories, one of them in Japan caught on fire, and you think, well, that's weird. Yeah, it did. In Taiwan, where they saw the blobs into slices and then they make chips on them, there's a shortage of water. So there's like a drought in Taiwan. Turns out they use a lot of water to make chips. In fact, they have to shoot the little pew pew lasers at the little blobs of silicon in order to like pew pew the chip on there. And then they shoot it through with water because that makes it work better or something. And they're running out of water. And so all these factors are kind of combining. We've got a global shortage of microchips. And the problem is that it's really hard to address this because it literally costs billions of dollars to make a new blob factory or a new chip factory or to get more water or whatever. And so even though we're in a weird situation where we've just had all of the chip companies basically recommit to spending like $100 billion each on new chip capacity, we don't got that capacity right now, which means that literally Ford F-150s are being built with no radios and no engine management computer because Ford can't get any chips to make them. And that's basically the weird story of the global chip shortage that we're in. Strange, huh? I don't know. Well, speaking of cars, it might not be the 1.21 gigawatts needed to power your time machine, but Apple has now committed to storing 240 megawatt hours of energy. The better news might actually be that 110 of its manufacturing partners are going to use 100% renewable energy. This is all part of making Apple's supply chain carbon neutral by 2030. What is Apple doing with all this electricity? Are they hoarding it to take over the world?
No, I think the best part is they're collecting it from the sun. It's really interesting that the main part of this announcement, kind of talking about grid scale energy storage product, actually piqued my interest. I was like, what are they storing? Where are they getting it from? And they actually are building just incredible amounts of solar farms to make sure that they are being a green and environmentally friendly, enterprise good player. And I want to see more companies doing this. I think it's interesting that we've got by 2030 that their whole supply chain and products will be carbon neutral. I can only imagine the total number of moving parts involved in making any enterprise's supply chain carbon neutral, let alone Apple's supply chain carbon neutral. So I applaud any enterprise who is going down this route. I would love for all of them to make these kinds of claims publicly so they can be held accountable by the public, by the people who are using their products. I can make decisions when I buy, that I'm using something that is, they've got good intentions on helping us save this planet. Let's move forward with more of this for sure. So, Stephen, the familiar tech field day presenter Vast Data just announced that they're going to stop making hardware. This isn't because they're going out of business, far from it. Instead, they're going to focus on delivering software as a subscription with others providing the hardware. Is this the way forward for enterprise product companies?
I think it might be. This is actually a really great move, I think, on part of Vast. So those of you who, well, I guess maybe didn't think of it because it's pretty obvious once you think of it, all these startups don't actually make hardware. Vast Data doesn't have like a giant factory where they're like, manufacturing silicon chips and stuff. No, they at the most get big cardboard boxes from China, stick stuff in them, and ship them back out to customers. And Vast basically has decided, you know what, we're not going to do that. Instead, we're going to have a company called Avnet build the hardware. And not only just build the hardware, but spec out the hardware and ship the hardware and support the hardware. And then we're going to basically have our stuff just be software that runs on that. I think this is great. I think more and more companies are going to do this. Already, of course, a lot of companies are doing this, like every software company. But you don't expect this in the enterprise storage appliance market or the enterprise networking market or whatever. I mean, you kind of expect them to be making hardware. But Vast is actually basically they're admitting what everybody knows, which is that they just use off-the-shelf hardware anyway. And so instead of just pretending they're not using off-the-shelf hardware, they're just going to let Avnet ship the hardware and support the hardware, and they're going to convert their company into a software business. And frankly, that makes a lot of sense. I think that a lot of companies going forward are going to be starting to look at this. The only gotcha here, and this is something that I heard when I talked about this to one of the companies in this space, is that there's actually a funny reason that you want to ship hardware, and that's because it makes your financials look better. Essentially, hardware costs a lot of money. And so even though you're basically paying money for the hardware and then turning around and flipping that hardware to somebody else, that money kind of passes right through you. It still counts as revenue. And so companies that decide to go to an all software model actually don't look as good to the VCs because the VCs like to see big revenue numbers. So essentially, I think that Vast Data, now that they've raised a vast amount of money at a vast valuation, and now that they've got a bunch of customers out there, I think that they're able to say, you know what, we're not going to play this game. We're just get your hardware from Avnet, get our software from us, and that's how we're going to work with you. Personally, I really like this model, and I think that we're going to see it more and more with storage companies. So now that we've talked a little bit about these shorter news stories, I think it's time to discuss the elephant in the room, and that is Intel and their Ice Lake announcement. So Calvin, I assume you watched, right?
Actually, I did catch the Intel's announcement today, and I've been super excited and waiting for this announcement. Probably as long as I've been waiting for Duke Nukem Forever to launch. They've been announced their next generation server platform, codenamed Ice Lake, and the company finally released these next generation CPUs yesterday. And they will address most of the concerns we've had with Intel server chips, namely cores, more memory, PCIe 4.0. But is Ice Lake a lot more than a new chip? What's your take, Stephen?
Yeah, we've been waiting for a long, long time. And in fact, for what it's worth, Ice Lake was originally supposed to come out in 2018, or maybe 2019, or maybe 2020. And here it is, 2021, and Ice Lake is here. Essentially, we've got a really weird situation where Intel was really, really delayed in releasing this new chip. And a lot of it comes down to manufacturing issues. They were waiting for their 10 nanometer process to get up to speed. Some of it was basically the fact that they sort of did a little switcheroo in order to give Facebook multi-core, like a many-core, many-socket chip last year. So they kind of nudged Ice Lake out of the way a little bit. But the bottom line is it's here. And so let's just kind of set aside the fact that we've been literally waiting for 2 years for this chip to come out. Now that we've got it, what do we have? And the answer is we have a pretty solid competitive offering from Intel. So as you've probably heard on the rundown over the last 2 years, AMD has been doing some pretty great stuff in the server space. So their EPYC platform, especially once they got to the 2.0 Rome version, was a pretty compelling server platform. So AMD was the first to have PCIe 4. They had a lot of PCIe channels. They had 8-channel memory. They had a lot of cores. And frankly, they had a very, very competitive product on their hands. And they started making major, major server wins in the cloud and in the data center. And Intel was originally supposed to announce Ice Lake even before that. Intel was supposed to be the first one with PCIe 4. But instead, AMD actually released their next generation platform before Intel. So that was Milan, where they've got 64 core CPUs. They've got all these, great SKUs. But the thing about Milan that was interesting was that basically it was just a little speed bump over Rome. There was no major architectural differences. Well, now we've got Intel here with Ice Lake. And so essentially, technically, this is the Xeon Scalable Processor 3rd generation. And for 1 and 2 socket servers. That's Ice Lake. That's what we're talking about here. And essentially what we've got is a product that has up to 40 cores of CPU for 80 threads, up to 2 sockets, so up to 80 CPU cores per motherboard, 64 lanes of PCIe 4 per socket, so up to 128 lanes per motherboard, 8-channel memory, with 2 DIMMs per socket. So you got up to 8 terabytes of memory on these things. This is not the absolute high-end server platform like AMD is delivering, but it is absolutely the server platform that the entire universe runs on. Theoretically, I think some people in Alpha Centauri are still using Cyrix, but they were Rich Stroffolino fans, so we're going to skip them.
Yeah.
So essentially, we've got this new server platform here, and it's pretty good. I think you watched the announcement too. Did you get that message, or did you get a different message from the announcement?
I got maybe a slightly different message from the announcement, although I do feel like Intel got bogged down in the weeds. I don't know what was going on. They seemed to fell a little bit behind. I think this is an interesting refocus on maybe the edge. there's all the data center things you talked about, the Facebook, re-architecturing of those CPUs just for various cloud vendors. This doesn't feel like a hyperscaler cloud vendor type play. I'm sure it'll be used there, absolutely. But I see a lot of value though in actually taking these CPU chips and getting them to the compute edge. The whole, I mean, if I kind of list down the other features that they announced, the deep learning boost, being able to actually have GPU like capacities right built onto the CPU chip, not have to like go outside that piece of silicon to actually be able to do some inference or model training and be able to train those models right at the edge with the same level of performance you may have gotten or better from like an NVIDIA discrete GPU. Big win there, I think. We're starting to talk about things like cloud gaming. Can they actually push these things to pops where the cloud gaming is actually happening at the edge, but actually at the edge really close to you, so you get great frames per second, zero lower latencies. So there's that whole gaming aspect they may have mentioned in there too. For me, the edge also means, how do I protect my code? I think edge locations may not be as secure as one of these hyperscaler type locations where they've got giant fortresses of availability zones in their various regions. We're talking about smaller edge locations, maybe vendors who can't provide a level of physical security that's needed. You need to be able to protect code that may be running at those edges. And I think that their software guard extensions, the SGX, was actually a really important announcement. It's in production now, but they increased the enclave size. They've increased the throughput you can run through one of these software guard extensions, which is going to allow us to encrypt our code and also allows for that zero trust computing. I'll be able to process data sets from multiple sources, multiple parties, and not have to expose my data directly to those other parties, but they'll be able to benefit from the generated or derived data coming off of those things. So big win there. They talked a lot about 5G. I don't know, what did you think about the 5G announcements? They talked about some antenna bits and some Ethernet 800 improvements. Again, this all really speaks edge. They really had a focus on edge computing here. So I don't know, where do you see Intel on the edge now?
Yeah, that's a real good point. And that's one that didn't come up in our Tech Field Day roundtable discussions yesterday, where we were kind of covering the announcement. A lot of us focused more on the data center, more the traditional data center, not the hyperscaler, but we didn't really talk much about the edge. Yeah, I think that one of the interesting aspects of this product is that it absolutely is designed to go all the way down, out to the edge, out to the lower end. There's a couple of really interesting SKUs in the list, including ones that have enhanced reliability, enhanced heat, or whatever, they don't need as much cooling. They don't need to be replaced, that sort of thing. So they're maybe not quite as fast, but they're designed for sort of ruggedized edge locations like you're describing. And for those of you who kind of have been rolling your eyes whenever a vendor talks about edge and 5G, here's the kind of the TLDR on that. Frankly, the secret of 5G isn't radios or cell phones or network performance. The secret of 5G is virtualized data centers everywhere. And so essentially what we're going to get, instead of, you see a cloud or a cell tower, right? At the base of that tower, there's a little building. In that little building, there's a couple of racks of server hardware, specialized hardware right now in 4G. In the 5G era, it's going to be more towers, many more towers. And in each of those little buildings is going to be shrunk down to maybe a half rack. And that half rack is going to have, frankly, Intel Xeons, flash memory, and virtualization. And it's going to run a lot of applications right there at the edge so that it reduces latency, like Calvin is saying. And so you can have your Netflix movie streaming from like the cell site that's a block away, instead of even streaming from some central location. You're going to have your gaming and so on, spread out at the edge. And that's the real secret here, I think. Now, there's a bunch of other features here that I think really help general purpose computing. You mentioned the DL boost. This is important. I don't know that people realize this, but no other data center platform has AI machine learning capability built into the chip. If you want to do that, you can either kind of fall back on the traditional, floating point math or SIMD instructions like, that chips have, or you can put in a GPU. But the GPU adds a lot more power and complexity and everything. The Intel chip actually has a special AI acceleration engine right there in the chip, and it's got instructions built into it that are specifically designed for machine learning applications, kind of like Apple does with
Well, I was going to
their
ask,
mobile chips.
how do you feel like this compares to, like, say, the M1 chip or the Google TPUs, the tensor processing units? I mean, are they aiming at those groups?
I think they're definitely in between. So it's
Yeah.
like the M1 chip that has the machine learning engine, but it's probably better than that in certain applications, but probably not up to the role of like the TensorFlow or something. I mean, Intel did claim that their high-end Xeon scalable third generation whatever Ice Lake CPUs can actually outperform an NVIDIA A100 by substantially in machine learning operations. But I don't think that that's really the ideal application for it. I think what Intel is seeing here is that they need to have special instructions and special hardware to support sort of AI everywhere. And I think that that's the real takeaway. So instead of saying, oh, AI is something that lives in the data center and that uses high-end GPUs, and or oh, Intel's going to like somehow challenge that. No, no, no. What Intel's going to do is they're going to put these things everywhere, and they're going to allow you to run AI everywhere. And another thing that my friend Fred Van Haren pointed out is that the cool thing is that if you're running that using x86 CPUs, you don't actually have to like recompile or make your application something special, right? You write it to DL Boost API, you write it to x86, you use the AVX 512 or you use the int8 instructions, and basically you can use a regular x86 compiler and just roll out an AI ML application on the server platform.
It's going to be even
really
it's going to be simpler than that, Stephen. People are just going to pick up Python, grab their Keras library, and it's going to know. It's going to detect that you've got one of these processors, ready to go. I'm just thinking of the energy savings alone, not having to actually have a separate GPU helping on the side processing this. So I think there's going to be a big benefit to, again, low latency edge inference. I think it's going to benefit from model training. I mean, if anyone who's done machine learning, I mean, you are constantly rerunning and regenerating your models. Having that speed up is going to be just a huge improvement to the quality we're going to see in the inference coming out later. A big difference there. Actually, I want to jump over they also announced, prior to this, their foundry capabilities, and they're going to be producing chips for everybody. Is that what's kind of coming down the pipe? I don't know. It's an interesting move by Intel that they're announcing a third gen, Xeon with all these amazing features, and they're like, oh, and by the way, we'll make your stuff too. But I am excited to find that it's going to, they're going to make those chips here with this increased capacity. Now, maybe that leads into your silicon shortage story too. But what do you think about the foundry capacity story?
Yeah, that's an interesting one too. I know that people like to give Intel crap because they're behind TSMC on the nanometer race, right? Oh well, they've got 7 and now they're going to have 5, and well, truly the numbers are kind of misleading. If you if you look at the Wikipedia article, it'll tell you that the difference between 10 and 7 is actually not what you think it is, and the difference between Intel 10 and TSMC 7 is a little bit of a different story. But the bottom line is Intel is probably a little bit behind the state of the art in terms of absolute manufacturing capability. But that being said, they also are able to produce their own chips on their own machines. Now, for a long time, Intel has tried to become what's called a foundry, which is basically, you give them your chip design and they basically make the chip for you. Intel kind of wanted to do that because the finance people kind of wanted them to do that, but they kind of didn't want to do that because they kind of wanted to make more Xeons. And so instead, what Intel did was they sort of just half-assed their way through this thing. Now they're committed. So the new CEO, Pat Gelsinger, who we have lauded to a great deal here on the Rundown, has committed, I think it was like 20% of their foundry capacity, to foundry, which is pretty cool because, and basically created a separate business unit to run this thing, which is pretty cool because it means they might actually do that. They might actually be producing chips. And Intel, I hear, is building a big new fab in New Mexico,
I think
which
so, yeah.
will be a big center for production. So I think this is a good move as well. And I think that it's kind of unrelated to Xeon, but kind of related to Intel not going out of business. I think that it's
Right.
going to be good for them to have like foundry partners and people making stuff. And also there's also the angle that you mentioned about kind of made here in the United States. There's been a big controversy over producing things in, South Korea or China or Taiwan, or Japan. Obviously, we have different relationships with each of those countries, and each of them have different relationships with different countries in our viewing, listening audience. It would probably be a good idea to make things in other places too. And so soon they're going to be making CPUs here in the US. I think that there are certain government agencies that are going to be pretty happy about that, and especially combine that with the foundry angle. And I think we've discovered an important angle for this thing. So essentially, we'll be able to have the the US government say, oh, no, 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 we want this chip manufactured in the US. And the answer is going to be, yes, we can do that, instead of, well, no, we can't. And actually, that goes to your SGX story as well. In my mind, SGX is a response to two stories that we've also covered in the rundown: Spectre and Meltdown, and the alleged Bloomberg big hack, where allegedly there was the snooping chip that was embedded on Supermicro servers, and it turned out it wasn't true. I think that the cool thing about SGX is that basically, like you said, you can run code on untrusted hardware. That's really what Intel is going for there. So combine that with the fab story, and you kind of start seeing that Intel is finding a really interesting path here to produce sort of government certified chips.
And there was another feature we didn't even talk about, which was the crypto acceleration and the homomorphic encryption, built into these chips too.
I don't. Okay, homomorphic encryption makes your brain hurt. It's going to make everybody's brain hurt. So here's the thing. You know that you can't, like, encrypted means you can't read it, right? Like, so if I encrypt a thing and give it to you, you can't read it. And if you can't read it, then you can't do anything with it, right? Well, homomorphic encryption says, I can give you encrypted data and you can perform math operations on that data without decrypting it.
This is incredible. I mean, I really, again, gets back to that edge computing. If what they say is true and these features do pan out, they can now make US versions of these chips. They can make Korea versions of these chips. They can have all these encryption features and enhancements. I mean, the crypto acceleration alone, they were talking about the advancements it'll allow for just speeding up logins. Think of the scale of some of these giant, internet properties, and what CPU power is wasted just logging people in, because you have to run bcrypt or some really CPU intensive encryption on it to get the hashes right. And now we can greatly scale and reduce the energy. Again, reducing energy, reducing heat, reducing the cooling. It's all win.
Absolutely. And I think that this is so this is really the takeaway here. The takeaway, this is Intel Strikes Back, right? So we had AMD with the EPYC, and they had their fun, and they were all out there, selling server CPUs. And then here comes Intel, and Intel says, guess what? We've created a server platform for the entire data center, for basically the vast majority of the market. It does everything the other guy does, pretty much. It's pretty much as good as what the other guy has. And not only that, but it has all these other things involved in it. And then there's one more thing that I'll bring up too, and that is that Intel has, over the last year, introduced additional supporting actors in this play. So they introduced the persistent memory stuff, the Optane PMEM 200 back in December. They also introduced the P5800X NVMe SSD in December. They released the Intel Ethernet 800 card. All of these made no sense on, Skylake. All of these make 100% sense on Ice Lake. In other words, why would you want a PCIe Gen 4 200 gigabit Ethernet adapter if you don't have a PCIe Gen 4 slot in your server? Well, you don't. But now that you do, maybe you want one, right? And so I think that that's the other thing, is that this is not just a chip. It's not just a CPU. It's part of a big platform. And the platform is, Ice Lake. And that, I think, is the takeaway story. Ice Lake is basically the new platform.
As a developer, I'm super excited because it gives me new features and functionalities that I can tap into to actually secure my applications. It's not just a CPU anymore. It's a platform full of APIs that I can leverage to secure my code.
Yep, absolutely. So I think that Intel did a nice job here. The other thing that I'll point out too is in our Gestalt IT roundtable that we did for Tech Field Day, we also pointed out that Intel has finally figured out how to market stuff, not by saying, oh, look, speeds and feeds and chips and pipelines and performance and stuff. They're marketing it based on, look at these cool things that you can do with this thing.
Mm-hmm.
And basically that's been kind of an Intel strong suit for a while, but it's not been a strong suit of the industry overall. Go back and watch the AMD announcement. But Intel's basically saying, look, this is a new awesome platform, but what can you do with it? What applications can you run on it? How can you use it? What does it enable? And frankly, that's, I think, the news here.
Yep, I couldn't agree more.
Well, thanks so much for joining us today. It's been great having you, Calvin, on the Gestalt IT Rundown, especially with this Intel news. Where can we connect with you and learn more about your thoughts on the topic of enterprise tech?
You can find me on Twitter at CalvinHP, and you can also find our blog at 6feetup.com/blog.
Well, thanks a lot. You can find my work on gestaltit.com, where I've just published an editorial about the Ice Lake announcement as well yesterday. You can also listen to my podcast, Utilizing AI, every Tuesday. And of course, you'll find me here every week on the Rundown. Remember that the Gestalt IT Rundown is published as a podcast as well as on YouTube every Wednesday at 12:30 Eastern. Just go to youtube.com/gestaltit video. We also post videos on our Facebook page, facebook.com/gestaltit. We'll be back next Wednesday with another episode of the Rundown to talk about the IT news of the week that was. But until then, for myself, Stephen Foskett, and for all of us at the Gestalt IT family, here's wishing you a truly memorable day.